Paul, you are available?
Yes, sir.
Are you ready with your presentation and all?
Yeah, sir. I am ready.
Right. Thank you, Paul.
Mhm.
Good morning, all. How many are there? Almost 34. Um, we will wait for another 2 minutes and we will start this session.
Very good morning, Bhuvan team.
Sir, we are there, sir.
Shall we start?
Yes, sir. We are there.
Okay, let us start then. We will, I think today's first. Good morning, participants. So let us start the day two proceedings. First, we have an interesting lecture that is Bhuvan APIs and implementations for applications development, and Mr. Manvendra Kumar all. He will be delivering the lecture. Before we start, if anybody has any specific queries, you can just put it in the chat, and we will have a question answer session after lunch, followed by hands-on session. So let us try to focus on the technical lectures before lunch. We have a series of lectures lined up. So let us start. And Mr. Manvendra, you can start. Mr. Manvendra, you are online.
Paul, you are not audible.
You have to unmute yourself.
Oh, okay. So good morning, all the participants. So today we are going to have the lecture on Bhuvan Web APIs and services and its implementation. So is my screen visible to everyone?
Yeah, it is
Yes.
visible.
Okay. So let's continue. So first and foremost, the question arises is what is an API? So if an overview or at the broader in the broader term, if I tell, so the API is a application programming interface, and it is a way for two software or applications to talk to each other and share information or services. So let us break this technical definition into that means understandable one or very smaller terms. So suppose if we are any web service or an URL, we are giving some input to it, and it will show some output. It will deliver some output. So that's the very broad definition if I talk about. And let's go move on to some daily example in order to understand more about this application programming interface. So suppose you went to some restaurant, and there you have ordered samosa or anything. Let us take example of samosa. So samosa you ordered. Now you want this product, whatever the product you want, that product you want, that samosa you want on your table, but you don't worry about that what is happening in the backend. So whether that waiter has taken your order, and then he has at the back end whatever the people who are preparing the samosa, and how much potato, how what content they are putting into it, and what masala they are adding, we are not aware about all those things, and we don't care also. We want the product, that is the. So what is happening in the back end, we are not aware. So similar, like same thing here also. The API, what we will give the input, we will give the input, and we expect the output, that how it is connecting in the backend, to which database it is connecting, what kind of information it is fetching, and how those backend things are going on, that we don't know also, and we don't care about. We need the output, that's it. So here, this is what the API does. So suppose in your application, your you have a large project or you have a large application. In that application, we call simple modules. We have different simple modules. So in that particular module, you want, suppose you have lat and long latitude, and for the geo, from the geospatial point of view, I am telling, suppose you have latitude and longitude, or you have the coordinates, and from those coordinates you want to know that what is the location of this, what is the address, what is the, to which state, to which district this particular latitude and longitude, or this particular coordinate belongs to. So what you do, you will give those coordinates to the API, and API will return the name of the state or name of the village or whatever the exact address for that coordinate, it will return. So how it has done that process, that we don't know. So from for that it will connect in the at the back end, it will connect to some database, and it will match those latitude and longitude and corresponding address. It will fetch and it will show you. So that is what the API is. I hope you all have understood this API. And many times when you see, when you build applications, several kinds of, I think I will say that millions of APIs are involved in that particular project, and millions of APIs are being called in that larger project. That with those modules, with those APIs, we are able to build a successful and major that means project. So that is what this API, how much importance it is, you can understand that one. Okay, now let's move to introduction to Bhuvan APIs and services. So what are the Bhuvan APIs and services, and what do they provide? So one is thing is this data retrieval. So you can access high quality satellite imagery. Here I am talking about the satellite service. Suppose some map service you have given, that is also one kind of a API. So there you call that particular URL, and it is a service, and it gives your the satellite imagery whatever we have in our Bhuvan, and some geospatial data for various applications also you can get from Bhuvan APIs and services. Second point is geospatial analysis. Geospatial analysis is like uh, from this we have many APIs which are like thematic based or some geospatial based. So from there you can do many analytics, you can the analysis on that one, and you can have some decisions based on those one that you will be able to know in the further. If I demonstrate all those APIs, and I will run through what are the different categories of APIs, then you will be able to know how this geospatial analysis you can do. And third is the custom mapping, also you can prepare using our one data sources. And application, yeah, it is of course you can develop the applications with these kind of APIs. You can merge into a single project, and different themes you can call, and then you can further develop this application. So, okay, so these are the one APIs. So if you, how will you get these APIs is whenever you open our this main one home page, our one nrsc.gov.in. So there you can see there is one and at the top of header only API section. When you click on it, you will simply go to our one web API. Now, so how many are there? Totally, if see, there are mainly basic four categories are there. One is proximity. Under proximity category, there are three major APIs. One is postal and hospital details, village geocoding, and village reverse geocoding. Village geocoding, I told you one example of village geocoding or village reverse geocoding, and these thematic stats are there. So land use, land cover, based on different skills. This API provides the information, and this routing is, as you know, that shortest path API. It will tell the distance, the shortest distance between the 2 points. And Joid is this ellipsoid to Joid conversion API. That if you want to know more it, how will you do? You just click on that particular category, and you under that particular category, these APIs will be listed, and you have to go to this hospital API. In this is all the documentation, it is there. So this documentation is listed out, and you can read it, that what does it do. In the introduction part you will know this what does this postal and hospital API do. It shows the details of the hospitals and post offices which are near to you, and you have to give the location details and buffer in meter. Buffer is like that radius. So how much radius, in how much radius proximity to you, that you want to get the detail. So how what are the inputs are there? So I was talking about the inputs, and it will show some output. So request parameters are the input. So latitude and longitude for this is basically for Andhra Pradesh. So you have to give the lat long for this whatever the lat long are there in Andhra Pradesh region, that you have to give, and buffer in meters. That means how much proximity you want. It can be 3000 meter or 5000 meter, 10 meter, 500 meter, like that you have to give. So it will list out all the, and theme you have to select, and some token you have to select. So on the basis of your input, it will show the output. So let me show you that how it is going to work. So just I will copy this URL, this one, okay, and let us say buffer is my 3000 itself. And after that I have to pass the token as well. Without token I will not get the output. So how we will get the token? So if you don't this, I will log out, because initially you will not be able to, that means you will not be logged in. So if you click on this access token, it will say that you have to log in to get the key. So you have to log in from here. So I'm just logging. Okay, once you logged in, you have to click on access token, and you have to select a theme. So currently with postal and hospital, this API only. So we will select this theme only, and we will try to get the access token. So it is we will simply copy this key or token, and we will paste it here. So what we are saying that what are the all the hospital and postal details are listed out there. With this is our point, this lat and lon, this is our point. With respect to that point, in 3000 meter radius, whatever those facilities, these postal and hospital facilities are there, they are being listed out. So suppose if you are developing any application with respect to where you are calling some proximity kind of function, and this proximity cannot be with respect to only this, this is limited to postal and hospital. It can be anything, different restaurant will can be there, or different other facilities also will be there. So that kind of thing you can implement, you can include this into your application and call this API, and will get all the details, and based on that you will be able to show the points, geospatial points on the map. And from there you can on click also you can display that what is the what are other details about that particular, that means what kind of hospital it is, and what is the strength, that means how the structure, and what are the address, and all those things you can display as per. So similarly, like village geocoding also, you can read this documentation, and you will be able to understand that what you have to do. You have to just give the name of your village here, like this village name is given, and again simply you have to get the token. I have already told you, because here village geocoding is there. So so you have to select this village geocoding theme, and then get the access token. You have to just copy this token and put in place of this xxx, and you will get all those details. That means what are the census, all the census details. But this is as per census 2001. So as per census 2001, you will get all the JSON. That means what is the village ID, what are the number of household, total population, total male population, total female, all those details you will be able to get here. So this is one of the example of village geocoding. Similarly, village reverse geocoding, it will be just reverse. You have to give the coordinate, and from the coordinate you will be able to know that what is the name of the village, and or other details as census details as it is. So I hope this is the very basic API which is clear to you. I hope you all understand this thing. And next is this coming to our geospatial analysis kind of thing. Something you can anyone want to ask anything, or okay. So coming to this LULC 50K stats, so this is it will show the land cover, all the stats it will show on the say 50,000 scale for the years 2005 and 6 and 11 12. So it will give these all the details. And from what you can read this, see one, if I do this URL, it will get the details. And you have to that means what are the request parameters. So request parameters will be like first 2 digit 4 digit, this is the district code. Okay, this thing is district code. So district codes are there, like these are listed out here, and state codes are also there, so you can read this. So as well as land use codes also, that means L01 is our this built up urban, and 2 is built up rural, and 3 is this built up mining, and all those things are there. Okay, so what is this? So this is our that means Khammam region, and for this, that means one, if you go to the one is this built up urban. So built up urban is having this much of area. Okay, so like this, it will be in a square kilometer. So 2 and 3, these are different. That means build land use codes. From here, you can refer it, and you can get that means what is the area of that particular um, land use. Okay, so this kind of thing you can get. And similarly, this was for a point thing, or um, some state or region. If you pass for that, you will get. And similarly, this is the area of interest wise. So here you have to pass some area of interest, and based on that area of interest, you will be able to get that which to which state it is belong. And in that area of interest, what is the area of our built up urban, built up rural, and other classes like this. If it will list only those that means land use codes for which we have the area. Otherwise, if we don't have anything in that one, it won't list out. So you can see here the 01, 02, 04, and 5, and this all those are missing, because in that it doesn't have any area in that particular area of interest in this one. So this also you can test. So similar like other, you can copy this whole thing, and that means this is I'm showing for the testing purpose. For you can include in your application. But one thing is this: it is LLC 50K area wise, so access token we will good for this LLC area of interest wise. So since we are selecting this area of interest, so here also we will use the same theme, and we will paste this token, and it will give the details. See, so these are the details about this one, state and all those things. So this area of interest, you can replace it with your own area of interest. So this is one of the things. Similarly, like this on 50,000 scale to 50,000 scale also, this different stats are there in the different format. So like if you want in JSON format, you can use this URL, and this is only for a single year. If you want to pass only single year, then you can do. Otherwise, for multiple years in JSON format, you can pass the multiple years like 2004 underscore 05, then 2005, since similar like others also. And if you want to display all data, then you can do year equal to all, and some token you can pass based on this theme selection, and then you will get this JSON like this. That means what is the year and what is the description under of that particular point, because here we are talking about this point only, because lawn and alert is there. So description of that particular point, on that particular point, what is the how our land is. So it is if it is run or kharif crop based or double, or so like that it will show all the description of that particular point now in that different years. Okay, so I hope you understand this thing. Similarly, like this 250K area of interest wise, here you can pass this area of interest. And then similarly again, if you want for single layer or different layers, also in JSON format, this also you can do. Okay, so one thing I would want to tell you is so here if you want this display of data for multiple layers in chart format or all layers in chart format, so this is for this you can use. So this thing I have already taken here, this URL. So this area of interest I have given, and this kind of chart in chart format I want to know, because suppose if I want to make some geospatial analysis kind of thing, so I will need this thing. Guys, I was telling that you can make some geospatial analysis based on these APIs. So let us see how we can make some analytics. So this is one of the example for making analytics. Is suppose you see that here all the years are being listed out. Okay, from 2004 5 to I think 2017 18, all the year range are listed out. Now let us compare these 2 years, 2008 2009 and 2009 2010. So here we are very much it is visible this kharif crop. If I see, so what was the area in 15.86 it was, and now if I see it has been decreased to 11.04. Similarly, like built up, if you see it is same as it is, but this current fallow land, let us see, it was 3.75, uh, and now it has been gone to 5.6. So based on this, you can make a comparison like this different land cover. That means what it was in which year, how much area it was covering, and now how it is covering. That means based on the different years, you can make some comparative analysis. So that is one of the things. So here all the years are being listed in this one, and this is the kind of API which we are giving in the format of chart as well. Okay, so this you can read here. It will be this suppose if here equal to all and option equal to chart. So this kind of the chart will be displayed. This you can call between 2 years also. If you want to compare, if you don't want to see all the years, you want to just compare 2 years, then you can give the input accordingly, because here it is written multiple years in chart format and single year also in chart format, so that you can understand. So this is I think a basic which I have gone through, and routing you all know. I think if you read this, you will be able to understand that we have to give two set of that means set of points. This is lat 1 lon 1, this is first point, and this is lat 2 longitude 2, this is second point. So it will calculate that what is the, it will give you the GeoJSON format. Okay, so it will give you all the points. That means point 1 point 2 like this. It will give the coordinate, that means route it will give it, and that route will be shortest path route. Okay, so this is very simple, and you can this you can
Sir, excuse
do
me, sir.
yourself and test also.
Excuse me, sir.
Okay, yes.
Hello. Yes, sir.
Mm.
Sir, I have a small doubt regarding this routing option. So,
Please ask.
sir, when we are using this routing option, the shortest path that it shows, suppose we want a path which is through a road, a paved road where a vehicle has to move. So, will it show? Do we have an option to choose that? Because the walking path might be different, something similar to Google Maps. Some areas we can reach by foot, but if you have to go by road, then it takes a different route. So how it will happen in this case?
Okay, so you want to to see that suppose that route should be through the road or something like.
Yes, sir.
Hmm. So in that case, this I'm not sure, but whatever the points you are giving now, that set of points, it will between that yeah, it will show the shortest path, but yeah, it will be. I think it will not be like suppose if
Paul,
you are
shall I
giving
answer?
between two. Hello, yeah,
Paul, shall I?
anyone want to?
Yeah. See, basically the it is the only one route. It will shortest path. It will identify and show, and where it uses the road information, that is which is digitized. We have a road network, and it is digitized, and it has given some rank. So each road will be designated with the type of road which it is, and the highest rank road it will choose, the best highest rank road it will choose, and it will give the path. It is like that. It may not use, for example, there may be a route in which you have a footpath versus a well established road. It will choose a well established road instead of a road path. That's how it is.
Okay, sir. So, sorry, that ranking and all, do we have to choose while coding or as an input?
No, here, yes, while generating the database, these things we have to take care. But the API explicitly doesn't give any option to choose which road. It will give you the best possible route, best possible moving route. It may, if you have an option like you have a well established road and you have a footpath, it will not choose the footpath route. It will choose the well established road. It
All
is
right.
that way.
Thank you very much, sir, for that clarity, sir.
Yeah, yeah.
We can continue, sir, with this session.
Over to you, Pal.
Okay. So I think I hope your doubt is clear. Okay, fine. Thank you, sir, for making this clear. Okay, so like this, all these APIs are there. So I think I have shown you all the this demonstration regarding the different categories of the APIs, and so this is very simple. Okay, let's move on to our presentation. So these were the different categories of APIs which I have shown you. So now this thematic stats, like I have shown you that already this API also I have shown you. That means how we are finding these stats of the given area of interest. But what is the difference in that means between suppose if in normal scenario and how much this web service is useful to us. So normal we talk about the normal scenario. In normal scenario we want to calculate for this stats of some area of interest. We should have that actual data, that means for that area of interest data we should have some say file or TIFF format, and then we will read that one, and then we will calculate some algorithm or tail where we will write, and on the basis of that we will find the stats for the given area of interest. But here it is quite easy. We have to just pass the area of interest into our web service and it will do everything on it. So this is the basic interest. And also here this is a very dynamic kind of thing. There it is you have to for the static only. So this is a lot of time saving, and this you can include in your application and can run on any dynamic area of interest also. So and now looking into the key features of one APIs are this easy integration. Okay, so this is very simple. You have to call this URL and if, by passing the inputs and the token, and you will get the output. So it's very easy, and some comprehensive data also it gives that wide range of satellite imagery and geospatial data also. If we talk about the satellite web services, okay, some visualization, this all these things will be there. Whether it is web map service or the satellite based services on the map. So next is this accessing this I already told. but this is in flowchart format. That means how we will be accessing Bhuvan APIs and how will you authenticate and authorize. So step one is you have to visit our Bhuvan APIs documentation, and you will read that all the details that what this does this API do, and then you have to register it. Suppose for logging in to getting the access token first, if you are a new user, you have to register it, and then you have to log in using the credentials, and then to obtain an access token, and then you can review the available API endpoints in the documentation. That means which API you need to integrate in your application, and after choosing that API service, you can prepare your request, you can prepare your input. That means what input you want to give, and then you can include the access token in the header of the request. And this as soon as you send this API request, you will be getting the response, okay, for further application development. Or the all the steps which are that means broken very lightly, and these are provided. And now these are types. What are the types of Bhuvan APIs available, or web services that I already shown you, and also this raster data and vector data there, when which we are this map service and our satellite services which we are using. And then coming to the geocoding services that I already shown you, that how it is translating the address into geographic coordinates and vice versa. And some user management, this authentication and authorization also, yeah, it is there. So implementing, how you can implement this Bhuvan APIs in your application. You can understand these APIs functionalities, and this they include this geospatial data services, and some guidelines are also there. And after that, you can set up your environment by installing necessary tools, and setting up. You can access the Bhuvan services, whether it is map based or this web services, and then you can use the API documentation, and then you can implement authentication by getting the token and all those things, and then you can include that particular API in your application, and you can test that application later on. Yeah. So thank you so much. So that's all from my side. Okay, so if you people have any doubt, you can ask me.
So this presentation where you have enlisted the steps how to use this API functionality, will we have access to this presentation later? Can we get this presentation?
Yes, it will be available.
Yeah, it will be available.
Thank you
We
very
will be
much.
providing all the that means whatever the presentations are having, we order the lectures. So all those presentations, I think it will be provided to the participants.
And
Thank you very much.
accessing this APIs, you can visit Bhuvan portal.
Ah,
On the top menu, you find all that
that
details.
I already shown you. I want one more time. I will show you. As soon you will go to our Bhuvan nrsc.gov.in, you will be landing to our main page, and from there on the header side, you can see this is APIs are there, right? So you can click it, and you can visit our Bhuvan API page. Okay. So from there you can have the access. The only the thing is this access token, whatever we are using for accessing that for getting the response, that will be only valid for 24 hours. That you have to keep in mind. So once the 24 hours is over, so it will be expired. Okay. So then you have to again regenerate that access token, and you have to use it.
Understood, sir. Thank you very much.
Thank you.
Yeah, these PPTs will be available. Yesterday's PPTs also will be available. Probably by today evening, we will try to share this. Thank you, Pal.
Hmm.
Thank you
Thank
for
you, sir.
giving elaborated lecture. And sir, Shivshankar sir, are you there? You can log off your presentation mode, Pal.
Yes, sir. That only I'm doing. Yes, sir. It is. I think it is logged. My screen is not shared now. Your screen is visible, sir.
Yes. You can see Dr. Leslie's presentation now on the screen.
Yes. Yeah, good morning all. I am Leslie and I'll be taking you through some of the geospatial solutions for data collection, analysis and decision making through mobile app and as well as the through Bhuvan web services. Um, if you see mobile applications for field data collections, we have already have almost like 112 mobile applications which are customized and being used at a different departments and ministries. Apart from that, you have almost like 32 applications are still active, um, and we are supporting it for different ministries. And using these mobile applications, we could able to generate almost like 220 million geotags by almost like 5 lakh users across entire India. And how we develop these solutions are basically we interact with different ministries, understand their requirements, and based on that we will decide which solution we have to do it. For it may be a mobile application, for it can be a geoportal, or it can be a remote sensing technique where we can give a solution. So we'll decide based on the requirements shared by different ministries and government departments. And after understanding their requirements, we actually jot down those and put it in the form of a basically software requirement document, and we share that to the user, and we get approval of the documented probably the solution, and then we start developing it, and then it goes through a scrutiny, different levels of scrutiny. At NRSC ISRO, we have a basically software design review team where it will review the design versus the requirement, and then we have to go through that and get a clearance from that committee, and then we have to design and solution, and then we have to again go through another committee where that committee will basically evaluate based on the requirement design how the software has been built, and then it will be launched. The software will be launched, and again we based on the request of the user departments, we do even conduct capacity building at different levels. It can be it can be a national level, like training of trainers sort of a training program. It can be, or it can be basically a state level program, or it can be even the user based, like for example who are going to use these solutions, they will uh, be trained, and then it will be operationalized on the ground. This is the entire gamut of things which we do when it comes to mobile app based solutions. Traditionally, how we have started this in 2010, 9-10 time frame, we started working on field data collection using a mobile. Those days we had only Windows-based mobiles. So we used to actually traditionally, if you see, we used to carry a map, we used to carry a proforma, and we used to go to visit field and capture information, whatever we do it, like be it using a camera, you capture the photograph of the field, and then you interview the field personals, and then you try to take the observations of the field. For example, if it is a crop based solution, we try to interact with farmer, which crop and which variety he has used and all that, and then we'll try to get information like how what is the process of irrigation, like for example it is irrigation based water source they have, or they have groundwater source for cultivating the crop. So these sort of information we capture, we put it, and then we come to office and we convert that into digital, and then we go for a analysis. Now, since mobile has come into picture, all these limitations it has overcome. Like for example, while converting analog information into digital information, there always a possibility of keying in the erroneous information. So that is overcome here using these mobile app techniques. And there is a huge time gap between the data collection and data analysis, and that is also being overcome. And if you are working with in any emergency based decision making support system, so this is also actually the mobile applications will overcome that limitation. This is the architecture which we have adopted. Basically, you have a mobile device, then you have basically an app which will support you to capture the information using a device features, and then you have internet connectivity in the field. Then you can directly communicate to the cellular network, and then you can transmit the information which you capture using the mobile app. And then at the data center level, you have servers which will receive the information from the network, and then subsequently it will organize, and it will you have tools to basically query the organized information and give it in the form of a browser interface. So these are some of the entire chain which we have adopted for almost these 10 years. And these are some of the basically technologies which we have used, Apache Cordova. Now we are using React, sorry, it is a spelling mistake. It's a React native framework. And then we try to use HTML, CSS, and JavaScript libraries to basically code that in the form of function, and then store information in the mobile in the form of the XMLs or JSONs. And then in the middleware, you can see Apache web server and PHP scripts are used to communicate between the mobile and the data center. And the data is stored in the form of database using PostgreSQL and PostGIS. And now we are started using different database software like MongoDB is also being used nowadays. Then at a client side, we try to use OpenLayers or Leaflet for map related information. And we do use the map server for raster data publishing, and as well as geo server for vector data publishing. So these are some of the architecture which we have adopted for quite some time. And these are some of the features. So since I am calling this as a field data collector, so this is we use GPS to capture the location parameter. We use the mobile camera to capture the photograph or a video. Then we, since the OSs, the Android or the Windows, now presently we are only working on Android and iOS. So Android-based solutions, the OSs are very strong, and then we can use user interface. We can customize the user interface to our requirement to key in or to select the information which you are seeing it in that field. Then if you have internet connectivity in the field, you can immediately push the information, or if you don't have internet connectivity, you can store it and then push it at the later stage. And when you push it, there is always a possibility of a communication failure. So we ensure that the data is pushed to the data center and it is residing in the database. Only then we communicate to the user that the data is successfully sent. If not, it will organize that in the send late unsent of location, and then you can push it again at the later stage when you have a very good internet connectivity. Then you have a delete option in the app itself. Like if you have wrongly captured the information, you can delete it. For example, you have already pushed that to the data center. Then you have an interface to reject the observation, and where in which it will not be used for any analysis once the data is rejected. And in the mobile application itself, we have a device ID generation where it automatically generates to identify a device versus the user profile. User profile consists of 4 parameters. Basically, it consists of username, mobile number, and the organization and place you belong to, and all that. So these information is tagged to all the observations which are pushed from the mobile to the server, only to identify the information who is sending and how I can control that information which is coming from field to the data center. So the controlling part is we call it as a controlled crowdsourcing, where we try to identify based on the device ID, and we can restrict the observation which is coming from that device into the data center. And eventually we had even the offline maps. So currently we are not supporting. We are supporting in terms of progressive web app option. But initially we used to actually push that cached data into the mobile, and then we try to use. But the satellite related information, we are not doing it at the moment. But the geotagging information, for example, if you consider it as a monitoring based application, we need to know the earlier stage of observation. So for that, we do use this offline based mapping system. So these are some of the parameters which we capture as part of the mobile application. There are some good examples. I will take you through some of the good examples. Then subsequently, I will take you through some of the details of the options which we have and how we are doing it. The first part is the Manrega mobile application. Under phase 1 in 2015, we have started this. Under this, we have actually mapped almost like 3.84 crore assets on the ground, and then we could able to analyze that information and derive some value added inputs to the ministry, so as to plan how best they can plan where there are basically needs are there. Basically, there are deprived zones would be there, and that zones need to be addressed. So for that, we have used initially. Then subsequently, based on the ministry's recommendation, we have adopted a third-party evaluator for whatever work we have done. So there was a questionnaire which is developed, and almost like 2% of the assets of 3.8 crore assets have been basically validated, and a positive result has come based on that. And then subsequently phase 2 is being brought up. And phase 2, what we have done is, this is basically a monitoring based solution, where we are trying to monitor the observation on the ground in 3 different stages: before, during, and after. before the work get implemented on the ground, there we actually geotag it. Using that geotag location, we ensure that the user is going to the same location and geotagging for the second stage. That we call it as a geofencing, which has actually brought out the transparency and accountability in generating these asset information on the ground. So that has actually brought out, and you can see like almost like 4.79 crore assets have been monitored under this scheme in 3 different stages. And newly in September, from September 1st, we have rolled out another new solution of Manrega. I will take you through that also in detail, where we are trying to capture the information in the form of a point, line, and polygon. So linear features are captured as form of line, and then the aerial area features are captured in the form of a polygon. Then this is another application like Pradhan Mantri Awas Yojana, where almost like 80 lakh beneficiaries are getting benefited to construct their own Pakka houses. And we do monitor these in 5 different stages: not started stage, foundation, lintel, roof, and completed stage. And then here also we are adopting geofencing because different people may be visiting these sites. So they should not geotag the wrong houses, or they should not go and geotag the other house intentionally or unintentionally. To avoid that, we have introduced this. And in this solution, we have a navigation facility also, like we can navigate using the map where you are standing at that location, and then subsequently where your targeted location is there, that you can move with using the satellite data. Then you have an option for bulk data uploading, because it is a very huge data. You have an attribute information about the beneficiary, the house stage construction, and the location parameter on that. And apart from that, you have an evidence in the form of photographs. And there are 2 photographs which are captured for every geotag. So obviously, these 3 file information need to reach the server. So it is a challenge for us to upload all the 3 in one tandem, one go. So all that is being handled in this. And then visualizing that information, completed houses are also part of this. So we are trying to showcase how these houses has been constructed in the mobile application. All that is part of that. So this is how it is. There is another good application like Commissioner and Directorate of Municipal Administration. For them, we have developed. It is basically for a government of Telangana. This is again they are in 2 phases. First phase, we could able to manage that with the 12 lakh properties, covering almost like 72 ULBs. And then in phase 2, seeing the strength of the data which is coming, they could able to basically generate huge amount of taxes, property taxes. Reason was any construction, if you have to take place, you have to take the approval for the construction. So generally, what happens is we have found that the approval is taken for probably a 2-room house, but whereas now if you see, there is a big bungalow in that place. So it actually attracts the reassessment. So this solution has enabled the department to identify the reassessable houses, and they could able to reassess the houses and generate huge amount of taxes in order of hundreds of crores. So this has actually inculcated into phase 2 sort of a project, wherein which we have tried to even capture the information like characteristics of the building, how the building is constructed, what type of construction it is, and the use of a building, like how it is being used, whether it is being used for domestic purpose or being used for basically for any commercial purpose. Then any facilities the government is providing to that building, like in the form of a municipal water connection, or it can be any other way. Then if it is used for commercial purpose, whether it is being like hoardings, advertisement hoardings are being used, or cell towers are being used in the construction on the over the buildings, and all that is being captured, because it attracts additional tax to it. So almost like 85% of the work is completed as of now, and they are in the verge of completing this project, and hope this is going to change the way the people look at it. And the advantages of this solution is being communicated at many firms, and the many states have come forward to adopt this. Seeing this, actually, central government has identified National Institute of Urban Affairs to actually put this solution on Upyog platform, where a single platform where you can adopt multiple states into this, and then they can raise the benefit of this sort of a solution. This is one good solution which we could able to do it. Then this is again the National Statistical Office, where we are trying to support urban frame survey. The urban frame survey is started in 1956, and every 5 years they take, and then they delineate the boundaries in the form of basically the block boundary, then IV unit boundary, then ward boundary, and town boundaries. Town boundaries are overall generated using this, and this has been done manually all these years. In 2019, we have proposed a digital version under using GIS environment, how we can do this survey. It has been adopted, and currently it has been successfully done as part of phase 1, and now they are doing it in the form of a phase 2, like 22 to 27 is a phase 2 tenure, where they are trying to capture the information. And about 8,000 towns are getting mapped using this solution. Every year we actually support that is International Day of Yoga for Ministry of Ayush. All these years we have been supporting them using this solution. This is one among them. And Harpat is another mobile application where we try to find out where the potholes are there. So citizen-centric solution this is. We floated that. This is for Government of Haryana, where we try to give this solution to the citizens. Citizens can geotag the potholes near their routes, and then that will get disseminated to the server, and the respective engineers are being alerted with this report, and within 21 days they have to address this. If not, it gets escalated to the higher level. So we have actually developed this, and we have transferred this technology to the CMO of Haryana, where we could able to recruit 2 project scientists, and then we trained them, and then we deployed the solution. So during the phase 1, that is the first year, we could able to achieve like almost like 22,000 citizens have downloaded this solution, and 21,000 complaints have received, and 14,000 complaints are addressed. And this is what the statistics, I think this was statistics just for within 6 months statistics it was. This is one good solution which you could get rid of. Then all these solutions, we started this with the scientific study initially. Fasal was the first mobile application where we have developed, and crop studies have been used for this, like information like type of crop, condition of the crop, where a sowing date, type of soil, and when what is the type of irrigation, all that is being captured using this. And using this information, they try to interpret using the satellite data, different type of crops, and they use this field data to evaluate that interpretation and bring out the estimate, the probable yield estimates every year. So 8 different crops have been identified, and this is being supported by MNCFC. We are basically developing the solution and we are supporting this. We have shared this solution for MNCFC for their consumption. The same way, Bhuvan Rui and Bhuvan, another jump is also there, jute board and cotton board. For them, we are supporting, and you can see almost like 80,000 observations we get annually. So they actually use this observation to monitor and as well as the understand the crop progress, and then corrective measures can be taken up based on the reported information on the ground. This is another good solution. Recently, I think in 2022, we have an MOU with the National Highway Authorities of India, where we have developed a solution which uses the remote sensing information and build a green cover index along the highways. And this green cover index using remote sensing technique, we capture and index it and classify it in 4 different classes, and then this information need to be validated on the ground. So all along the highway at different intervals, we actually identify the location, and geofencing here is also inbuilt in it. The user has to go and geotag the field information and report back. So every 100 meters, how this green cover is there, that is being computed using this remote sensing technique, and then appropriate improvised on ground solutions are being taken up to improve the green cover along the highways. That's all I have. These are some of the basically the technologies which we have adopted in bringing out the solution. If you see here, geofencing we have used, how we have used, we are dynamically generating a GIS layer in the Android mobile, where geofencing layer, traces layer, then beneficiary layer, all that layers have been generated, and overlay operations, overlay analysis operations have been carried out, and then we can generate the alert system in the real time. Basically, for example, if you see on the top right image, there is a geofence, and an individual is moving into the circle, geofencing. If you are this fencing is basically some activity can happen within the circle, or it can be happening outside the circle. The first example is basically a COVID based example. There is a COVID patient, and there is a fence developed over the COVID patient residence. So if anybody going inside the circle, an alert will be given to the person who is entering into the circle, and he can restrict himself in entering into the circle. So that was a mechanism which is adopted here. And again, for geofencing is another way where for geotagging purpose we are using it. So here in this case, what happens is we ensure that the person enters into the circle and only carry out the geotagging activity. So such mechanism is being built as part of this. So the examples are Manrega solution, Housing for All, CDMA. These are solutions which we have adopted this. Then if you see in detail, Manrega, if you take, we have, as I told you, like we have moved to basically the geotagging of features in terms of point, line and polygon. The example here which is given is polygon, where the option is given to start and stop the activity, tagging activity. So there are three parameters which the user has to capture. The first part is basically initiating the GPS. First, they have to select the beneficiary or the asset in which they are going to capture the information, then capture the geolocation parameters in the form of, based on the asset type, it will identify whether it is a point, line, and polygon. So in this case, it is a polygon. So this is a form pond which they are trying to capture. So the start point, the user has to go and stand near the start point and click on start GPS. Then he has to move around the form pond, and then he can stop where it is a red mark is being showed, red dot is being showed. He can stop. Reason is it will automatically connect since there is no deviation in the capturing shape. So you can stop there. It will automatically connect, and it will generate the perimeter of the basically the form pond as well as the area of the form pond automatically, and it will show the user how where he has to take the photograph. This is another example how the user is being showcased. Is being intimated in the form of a map where he has to take the photograph. This is basically a circular feature wherein which he has to capture that feature. Basically, it is a plantation which is happening within the circle. So he has to move along the circle, then capture. Once he captures it, then the system will identify from where he has to take the photograph. So the circles, geofences are generated. So you can see like three different colors. Initially, based on the perimeter of the area in which the data is captured, the system will decide how many photographs have to be captured. In this case, the 4 photographs need to be captured. So the user need to enter into the circle and take the photograph of the area in which he is he is doing the plantation activity. Then subsequently he will go on to different circles, and then he will take the photograph. Once he enters into the circle, the color of the circle will change to red, because it is dynamically it is checking where you are. The orange icon represents where you are, and the blue icon represents where you have to go and take the photograph. So that's how it is. And then once he captures the information, the color of the circle will convert into green. That means the person need not take the photograph in that circle, standing in that circle. All the blue circles he has to address. That's how the solution is developed and put up. The same in case with line feature also. Instead of polygon, the person will capture in the form of line and take the photographs and features. We have a unique solution like how the GPS stabilized that we compute. Like we compute standard deviation for last 20 observations and generate, and we ensure that the standard deviation is more than 0 and less than 0.5. Only then we allow them to capture the GPS location, which gives a good result in this. So you can see like the people who are capturing information in the field, they are not well versed with this sort of a technology and the information. So we give it in the form of 3 dots, green, red, and orange dots. We tell them like if it becomes green, you capture it. If not, you don't capture it. So they have to wait at that particular location until it becomes green, and then they can go for a capturing of location. That's how that mechanism is built. So there are many applications like Pradhan Mantri Awas Yojana, CDMA, Fasal, crop cutting experiment are all the solutions which this sort of analysis is being inbuilt in the solution. The offline data caching is another activity which we have done, but currently we are not supporting it. For Manrega, basically the assets, they want to see it over the satellite data. So the satellite data has been cached and pushed to the mobile so that they get disseminated into the mobile. And then if you open that in the map form, they can get the satellite data where there is no internet connectivity. For that sort of mechanism was developed. Then any information which is there in the mobile are always prone to tampering it. So we do encrypt this information in the soft mode, and when we push that information, we decrypt, and we also check the authenticity using hash value, and then push the information. If it is even a single pixel is tampered with respect to photograph or the information which you captured, that will not allow you to upload that information to the server. This is again, as I told you, like it's a real challenge, like 3 different files at one tandem, it has to move to the server. You can't push the parcel information and then wait till the parcel in other part of information to come and reside in the server. So we have to ensure that all this information is there. So bulk data uploading is one option. We try to store the photographs in base 64 and then we push it to the server. And again, any information which we capture using a camera, it actually attracts data compression, because nowadays the cameras are very high-end cameras. You will end up in taking 20 MB photographs, and which are not required to push that to the server. Based on the solution, if I am using a solution where I have to take the photograph of a building, I can use very low resolution photograph. So I can compress this photograph to ensure that it occupies very less space. And if I am doing any crop related study and I have to understand the health of the crop using the photograph, in such scenario we don't compress it, we push it as it is. So that's how judiciously we take the move and we develop solutions. This is again map services. We have an MOU with MapMy India, and we try to support the navigation related services through this. We have our own data also apart from MapMy India. That also we try to use it. This is again basically a Gagan based receivers, a Bluetooth based receivers. This is available in the market, and we develop solutions which will support this. In fact, it has started as a MTech project at NRSC. We could able to develop this device, and then the student has opened his own organization and started selling this. And subsequently, it got spread to different organizations, and many organizations are developing such devices. This Gagan device actually supports in improving the XY coordinates, the accuracy of XY coordinates. Like us, the mobile GPS will give you an approximately 8 to 10 meters absolute accuracy, but whereas this Gagan based solution will give you almost like 1 to 2 meters accuracy. So the examples are basically where we can adopt is property related mapping, where you want to draw the boundary. There we can adopt it, and not precisely to the approximation level. Then apart from that, the forest plantation boundaries which are there, which are adopted by different forest departments like Tripura and UP, they have adopted it. And mining boundaries are also can be used, and it can be, Gagan devices can be used to map that. Then again, Navic also we have developed. Proof of concept was developed by us for potential fishing zone based solution, where MapMy India has taken up this solution, and they have integrated the solution as well as the device into a single device, and they're selling as a product. This is another good example. So that's all I have. I think I have completed in time. Any questions you have, kindly raise. If not, you can mail to us, bhuvan@nrsc.gov.in. Over to you, Shiv Shankar sir.
Yeah, I think now any questions, participants?
Yes, sir. So it's wonderful. So many apps have been made, and sir has given so many examples. Sir, any of these apps are are they in open domain that we can check out ourselves their functionalities and all?
The basic level of application is available on Bhuvan. You can see. You can type Bhuvan POI, point of interest. It is a generic application where you can geotag the public facilities and push to Bhuvan server. And we are trying to generate a database and which will be point of interest sort of information. We try to host it on Bhuvan. The many of almost like you can see almost like 1 million observations we have received till now, past 10 years, and it has been hosted on Bhuvan. That is one solution. Most of the solutions are basically ministry based and it is classified. Only the classified people can geotag that and push it. For benefit of the citizens, we have this. And then there are another applications like Pocket Bhuvan, which is again navigation based solution that also you can download and then see it. It is basically a navigation. You can traffic related information, all that is also being integrated in that. We are taking the support of MapMyIndia to develop that. Because the services, road services and the traffic related services, point of information services are getting from MapMyIndia, and we are floating this solution.
Okay, sir. And sir, the MapMyIndia is taken on this Maple. So is Maple also one of the similar products?
Yes.
Oh, right. Thank you so much.
All these cars, the Maruti cars which you have map, right, in that? Yes, those are all MapMyIndia's maps only. They have a very huge setup because almost like 1,000 people are working on the ground. So we can't afford that as a government agency. So what we have is we have an MOU with them. We give the satellite data service to them and they give in turn these services. So both organizations actually gain, both have a win-win sort of a situation. So they use our maps satellite data service and we use their services. That's how it's
Thank you so much, sir. Very insightful and detailed presentation.
Any other questions? Sir, over to you, sir. Thank you.
Yeah, I think any other questions from participants? Okay, if there are no questions, we will move to the next lecture, that is system infrastructure by Mr. Sharat Kumar. And if you have any other questions, you can also put it in chat. But otherwise, we'll start with the next session. Mr. Sharat, you are online. Sharat?
Just a moment, sir. I'll just find it.
Ah. Sharath?
Sir, just a moment, sir. I
Okay.
understand from there that some emergency has come up. So Saurav may
Oh.
take up this. Yeah.
Okay, fine. Then if Saurav is ready, then we will move to the next session. That is Bhuvan
Vastunaradhira?
Data Science.
Hello.
Hello, hello, Leslie sir.
Ah.
I am there. I am here.
Sure.
I can.
Sharath, you are here? Yeah.
Yes, sir. Yes, sir. I am here. I am ready.
Okay. Okay. Now you can start your lecture.
Okay, right. I will share my screen, sir.
Okay.
నా ఫైల్ అక్కడ తీసుకున్నా. Sir, this screen is visible, sir, or
Yeah, it is visible. You are also audible.
yes, sir. Good morning, sir. Sir.
Good morning.
Yeah, good morning to all.